Look, a shiny butterfly drifts across the sky, and as soon as you blink, it's gone forever. In this world, anything you see once, you never see again. How can we learn about planets, physics, or even basic colors? Zoe, the curious tinkerer, scratches her head and grins. Let's do a science trick, she whispers. First, Zoe builds the mirror maze telescope. It's not a normal telescope. Inside are thousands of tiny mirrors angled like the walls of a kaleidoscope. The idea, light from a distant star bounces around so many times that no single beam ever reaches your eye directly. Instead, the light scatters inside, weakening the magic rule that seeing once means never again. By the time the combined glow reaches Zoe's eye, it's like meeting the star for the very first time again. She records its twinkling pattern, writes down its color shifts, and measures how those tiny flickers change over hours. With those notes, she calculates the star's temperature and size, proving we can study distant suns without losing them forever. Next, she tackles falling apples. Normally, if you watch an apple drop, you never see it drop again to test gravity. Zoe's solution? The echo sensor. She places a gentle sonar pulse near the apple. The pulse sends out sound waves that bounce off the apple and return to a hidden recorder. Zoe never hears the ping herself, only the machine does. Because her eyes never see the apple drop, it never vanishes from her view. She glimpses it, turns away, then watches the machine's glowing screen light up with echo. From echo delay, she figures out how fast the apple fell. She confirms Newton's law of gravity without ever losing sight of the apple to her own eyes. But what about colors? Zoe wants to know why leaves turn green. She invents the Photon Net, a fine mesh of ultra-sensitive fibers laid over a leaf. Each fiber captures photons and sends them into a computer pixel by pixel. So it never looks directly at the leaf. She only watches the digital image on her screen. When she finishes, she lifts the net and gazes at the leaf itself. Still green, still there. Inside her computer, she sees millions of green pixels dancing. She measures the leaf screen wavelength at 550 nano, proving photosynthesis absorbs red and blue light and reflects green. Finally, to cast motion itself, Zoe creates the quantum cloud box. She places a tiny ball in a sealed fog chamber filled with microscopic, glowing particles. When the ball moves, it disturbs the cloud, leaving bright trails. Zoe watches a live feed of those trails on her tablet. The ball's path appears in neon lines, but to her eyes in the lab, the ball itself stays hidden under a shield. Only the glowing fog informs her. She rewinds the video, studies each curve, and derives the ball's speed and direction. At the end, Zoe stands triumphant. She used mirror mazes, sound echoes, photon nets, and quantum fog, all clever tricks to observe phenomena over and over without ever seeing them twice. In this topsy-turvy world, science still lives. It dances on the edge of what we can observe directly and what we infer with instruments. And even if your eyeballs can't catch a second glimpse, your mind can chase the mystery. Piece by piece, until the universe unfolds its secrets all over again.